Okay, in the previous lectures we did proving logical equivalence using truth table. Okay, we are going to use that again to prove the result that P implies Q is equivalent to, logically equivalent to negation P or Q. Okay, so the proof will be of P implies Q is logically equivalent to negation P or Q, and we have the truth table P, Q. How many logical connectives do we have? Two statements. How many logical connectives? 1, 2, 3. So 2 plus 3, we have 5 columns. We need 5 columns. We need P implies Q, then there will be negation P, and finally we'll have negation P or Q. So in 5 columns and in 4 rows we can prove this logical equivalence. The rows will be true, 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 false, false, true, and it will be false, false. So let us see how it works for this combinations here. True implies true is true. True implies false is false. False implies true is true. False implies false is true. Okay, so implication is false if and only if there is this case where true implies false, where the first is true and the second is false. Only in that case we get implication as false. In all the other cases it is true, as you know we have done in the previous lectures. Now negation P will be false, false, true, true. So negation P is false, false, true, true, right? And negation P or Q we will find out now. So negation P or Q, when we are finding, it is we are taking all of this with Q. So it is false or true, giving you true. False or false, giving you false. True, true is true. True, false. True or false is again true. Okay, so looking at this column number 3 and this column number 5, we have proved that P implies Q is logically equivalent to negation P or Q. Okay, so we can also then say that P double implies Q is logically equivalent to P implies Q and Q implies P. It can be proved using truth table. So that is double implication, that is biconditional. So from one side you can say P implies Q, and from the other side Q also implies P. It is similar to A is a subset of B and B is a subset of A. That means A is equal to B. Double implication means equal sets. Okay. Now this further can be written as negation P or Q and negation Q or P. Negation P or Q and negation Q or P. Okay. So this is what we have proved using truth table. Important result will be used in future. Okay, so this is one thing. Next, true, false, true, 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 false, true, true. Okay, P implies Q, negation P or Q, they are logically equivalent. Okay. Okay. Now, next is the definition of converse. Now, if we have P implies Q as a statement, then the converse is defined as Q implies P. In converse, what you do is just interchange Q and P. Here we will say A is a subset of B. In previous lecture I have told implication means you have to use the subset theory. So here we say A is a subset of B, and in converse what happens is you interchange those and say B is a subset of A. So when you are taking converse, what you are doing is you are writing it ulta. Q implies P. Okay, inverse. In inverse, it is negation P implies negation Q. So we have P की जगह पे you will have to write negation P. We have Q की जगह पे you will have to write negation Q, and implication sign will be there. So it is negation P implies negation Q. And then there is contrapositive. In contrapositive, what we have is, it is negation Q implies negation P. It is like we have to interchange this with a negation sign. Okay, so we'll interchange P implies Q with Q implies P, and we put a negation sign there. Okay, now one interesting thing is, if anybody asks you to take inverse of converse, that shall give you contrapositive. Okay, inverse of converse is contrapositive. We can say converse of contrapositive is inverse. We can say contrapositive of inverse is converse. I'll prove it. See, pay attention. When I have to find out converse of contrapositive. Converse of contrapositive of P implies Q. So first we are going to take contrapositive of P implies Q. So contrapositive of P implies Q will be, so we have converse of contrapositive of P implies Q will be negation Q implies negation P. And converse of negation Q implies negation P will be negation P implies negation Q. Isn't this inverse? So first I do contrapositive. Contrapositive means you're going to interchange Q and P and write the negation there. So it is negation Q implies negation P. And then we are going to take converse of contrapositive. When we take converse of contrapositive, we just interchange these two. We don't take negation, we just interchange the two statements and we get negation P implies negation Q, and this is inverse. So just like this you can prove the remaining. So inverse of converse is contrapositive. Converse of contrapositive is inverse. And it works in the reverse direction also. If anybody asks you what is converse of inverse, I repeat, if anybody asks me what is converse of inverse, converse of inverse, so that is nothing but that is converse of negation P implies negation Q. Converse of inverse, right? Converse of inverse of P implies Q. So converse of inverse of P implies Q. So first you find out inverse of P implies Q. So we just put negation signs here, and it is negation P implies negation Q. And then I want the converse of it. So when I want the converse of it, it becomes interchange. And that is contrapositive. So converse of inverse is contrapositive. Converse of inverse is contrapositive. Inverse of contrapositive is converse. Contrapositive of converse is inverse. Okay, so you can do it in both the ways. You can do it in clockwise direction or you can do it in anti-clockwise direction. In both the ways, it means the same. You can take converse of inverse, you get contrapositive. You can take contrapositive of inverse, you get converse. Okay, and these are the definitions of converse, inverse, and the last one is for contrapositive. Okay, next. Converse, inverse, contrapositive. Okay. Now, next is I'll give you a few statements if a person is rich, then he is correct. Okay, so the statement is if a person is rich, then he is correct. It's an implication. The second statement is if a person is rich, then he is not correct. Okay, I'll give you the third statement. The third statement is if a person is correct, then he is rich. Fourth statement, if a person is not correct, then he is not rich. Fifth statement is if a person is not rich, then he is not correct. Sixth statement is a person is not rich or he is correct. Okay, so we have if a person is rich, then he is corrupt. I can say the first part is antecedent, that is, if the person is rich, we can write that as P. He is corrupt, we can write this as Q. Okay, and the symbolic form for this is P implies Q. So if a person is rich, then he is corrupt is P implies Q. So you see the statement here, if the person is rich, then he is not corrupt. So in this it will be P implies negation Q. Okay, person is rich is P, not corrupt become negation Q, we have P implies negation Q. Okay, when we have here, if the person is corrupt, if the person is corrupt, that means Q has come ahead. Behind we have P. So if the person is corrupt, so symbolic form for this, if the person is corrupt, then he is rich, becomes Q implies P. Now, if the person is not corrupt, then he is not rich. In this case, it becomes negation Q implies negation P. Okay, so you must be now saying this is implication, this is converse, this is contrapositive. Then we have a person is not rich, P is rich, negation P will be not rich, then he is not corrupt, can be taken as negation P implies negation Q. And the last is if the person is not rich or he is corrupt, will be taken as negation P, rich not rich, negation P, he is corrupt will be or Q. Okay, so these are the statements here, and this is the symbolic form at the side here. And now I want to find out which statements are logically equivalent. Okay, for that you will have to say P implies Q. We will make a truth table itself here, P, Q. And then I'll put it like this, we'll put negation P, negation Q, P implies Q, Q implies P, this converse, then there is inverse, then there is contrapositive. This we did in the last before this only, before I wiped the board off, we did this. This is equivalent to P implies Q. So already we got one as equivalent to P implies Q. Already we now know that the sixth and the first statement, the first and the sixth statement are logically equivalent. That is done. This is remaining P implies negation Q. So I'll make a truth table for that also. P implies negation Q. Okay. So let us make the truth table for the statements here. I have written down the symbolic forms and now I'll create truth table for this. The truth table will be like true, true, false, false. When we have true, false, true, false. Negation will be false, false, true, true. And negation Q will be false, true, false, true. Okay, so then we have P implies Q. P implies Q, as you know, we have done it many times now. It will be true, false, true implies false will be false, and then true, true again. So only in that case it will be, okay, so it's true, false, true, true. Only in this case we'll have true implies false as false. Okay. Q implies P, Q implies P, true implies true, true, false implies true is true, true implies false, false, false implies false, true. So in this it will be true, true, false. When you're going ulta, true implies false. In other cases, true implies true, true, false implies true is true, true implies false is false, false implies false is true. So only in that case, where we have true implies false, we have false. Okay. Now we have negation P implies negation Q. So negation P implies negation Q is false implies false is true, false implies true is true, true implies false is false, and true implies true is true. Okay, so I can see that key in this column and in this column, you can see the truth values are same. Right? So we can always say that converse is same as inverse, logically equivalent. They are logically equivalent. You can see the truth values. They are logically equivalent. Converse and inverse are logically equivalent. Okay, then we do this negation Q implies negation P. So we have negation Q implies negation P. False implies false, true. True implies false, false. False implies true, true. True implies true, true. So only in the second case we are going to get false. In all the other cases we are going to get true, and therefore I can say that these are logically equivalent. These are logically equivalent. The statements here are implication and contrapositive. So converse and inverse logically equivalent. Implication and contrapositive are logically equivalent. Implication, contrapositive logically equivalent. Converse and inverse is logically equivalent. Let us see the last one where it is equivalent to what? See, this can be remembered as theory. Always. For P implies Q, converse, inverse, and this is contrapositive. For P implies Q, this is converse, inverse, and this is contrapositive. And we can always say converse and inverse are same. And we can say implication and contrapositive are same. That can be remembered as theory. This is just additional. We can just check whether it is becoming equal to any of these statements or not. So let us take P implies Q. P implies, negation Q. So P implies negation Q. We have true implies false. P implies negation Q. My first P here, true implies false, is false. Okay. Then we have true implies true. True. False implies anything will be true. So true implies false is first only false. True implies true is true. Okay. Then we have false implies false and false implies true as true, true, right? So there is no connection with anybody over here. Everywhere we have first as a true statement only. Here we have first as false. So that is not logically equivalent to any statement over here. So which out of these are logically equivalent? I will say P implies Q is logically equivalent to its contrapositive, that is fourth statement, and negation P or Q, we proved it earlier, are logically equivalent. They are the same. So 1, 4 and 6. 1, 4 and 6 are logically equivalent. Then we have 2 not matching with anybody here. Q implies P. And fifth statement we have is inverse. Converse and inverse, as we proved in this, are logically equivalent, 3 and 5. Second statement is not matching with anybody. So we have 1, 4, 6 as logically equivalent. Implication, contrapositive, and this is negation P or Q, which P implies Q can be written as. They are logically equivalent. 2 is not equivalent to anybody. 3 and 5 are logically equivalent. Because converse and inverse logically equivalent. Implication and contrapositive logically equivalent statements. Okay, so this is example of the theory inverse, converse and contrapositive. The definitions are to be remembered, and this will be the sums of it. This type of sums. Okay.